equation means equation, sorry. One element will be, for one element we get 48 equations. But the thing is, here we can able to count the number of elements, how much they are. So then we can easily calculate how many equations we are getting. Why? Because 48, suppose for example, if we have 100 elements, so 48 into 100, 4800 equations we will get. So if we count the number of equations, then we can easily able to solve it. Okay, so that is the reason we are performing the meshing here. Understand this one? So that is the reason, the main purpose of performing the meshing work. Now see here, for meshing we have three different, like for 1D we have different type of elements are there, for 2D we have different type of elements, and 3D have different types of elements. Suppose for example, if I am going for 1D, for 1D I have for 1D we have the elements like word line, bar. Here we have line, not line actually, bar, dots. These are the elements we can find in 1D. If you go for 2D, we can find here quad and tria. Short form, like we can say as a quadrilateral or triangular. Tria or quad, two elements we can find here. How the shapes are there? Quad is like a square ball, and tria is triangular shape. That is the difference you can find between quad and tria. And I said about the node. So what is node here? Node means these end points we can say as a nodes. By joining this node only, it will create the element. I said we have maximum 8 nodes for one element, but here it is showing only 4. 4 is a thing, but it's a standard one. If you want some advanced one, means what they will do, it will create here also one node to cover the complexity of the object. The object is very curvature, in that case we will use this 8 node element. Usually we will not use 8 node element. Why? Because if you take means you will get accurate results, but it will take more time for solving. That is the reason. See here, whenever you are performing any kind of analysis, we have to initially only we have to check what are the inputs are given there, time consumptions. You have to imagine how much time it will take. That thing also we have to take care. Based on that one only we have to check how many elements and what kind of meshing we have to perform. Okay. Now see here we have 8 nodes. In triangular element we will get minimum 3 nodes. Here and here. If it is some curvature shape, on curvature shape performing meshing means we will increase some 3 more nodes like this. So 6 nodes you can find in triangular element. Okay, that is quad and tria element. The next thing is 3D. In 3D we can find hexa, tetra, pyramid, like that. Different kinds of elements are there based on their shapes, but usually what we will do means we will use only these two, hexa and tetra. These two only we will use here. Okay, only these two, like hexa and tetra, only we will use here. Remaining penta and pyramid usually we will not use. And one more thing, remember here, sometimes we can find the term like bricks. Sometimes you can find the name like brick. So don't get confused. Brick means hexa. Okay, the shape is something looking like it's a 3D of box. 3 your hexa element. This is like a rectangular cube or cuboid we can say. Triangle is also same like that only. Tetra element also like that only. Suppose for example, one triangular element. This is your tetra. Tetra and hexa elements are there. So if the object, so I already explained you what is 1D, 2D, 3D. So in those cases we are using this kind of machine. Okay. Now we will go to the software to check how to assign these machines. Now come to analyze Ansys software, guys. Going for the operation directly from here also we can take machine part. Model we can take here. But it's better to go for some analyze only. From here onward I am going to machine. First I am importing the geometry. Machine. Okay. Okay. So geometry imported, go for mechanics. Now see here, this is my geometry. First of all, here we have the mesh. First of all, I am generating the mesh. Procedure will be same only, like we are till now we have done so many times. We will generate the mesh, but when you come to see here, you can find that it is creating. See here, you can able to see triangular element. Triangular element means it's a tetra. In 3D, if you find, I have the see. If we finding that this triangular element, when in 3D, that is your tetra element. Why? Because yeah, it will directly see here. If it is a hypermesh software, we can see each and like we can manually do one by one machines here. Wait a second, guys. Yeah. Now see here, this is my machine. Like without any settings I have done, I just generate the mesh. Like defaultly it will take some whatever settings previously was there. That setting it will take and it will generate the mesh. Like initially it is a triangular element or tetra element. Based on that one only. Based on that one only it will generate the mesh. Now we will perform the one by one settings. We will check one by one. So first of all, what we will do the settings here. First to go for select the mesh. Here you can find the details of the mesh. Like first of all, we will check what, see, whenever you're performing the meshing now, so first of all you have to take what kind of analysis you are doing. For different things we are using different analysis. Okay, for different things we are using different analysis here. For different things we are using different analysis here, and based on that analysis only we are performing the meshing here. Suppose for example if we are going for the mechanical or static structural like structural analysis, so that one we can say as a mechanical analysis. Okay, so if you are performing that one, you have to choose the option like mechanical. For example, if you are not using, if you are doing any other kind of analysis, you have to go for the option like if you are performing the CFD analysis, if you are performing the explicit dynamics analysis, if you are performing the electromagnetic analysis, so based on those things we are performing the, we are doing the meshing here. But mostly what we will do, we are performing the mechanical analysis only. In that case we have to go for mechanical analysis, and based on the like, yeah, based on your requirement, based on what kind of analysis you are performing there, we have to choose the option here. The next thing is relevance. So what is relevance here? Relevance is a thing word. For example, if you're performing the analysis here now, so in that case, right? Okay, relevance, what it will do means it will make your mesh somewhat sensitive. Like see here you can find very worst like worst type of machine you can find. See here we can find some different size. Here we can find some different size. So like different size of machine it is making here. So but when you go for the relevance, here we have two types of relevance are there. One is positive relevance and one is negative relevance. If you go for positive side, like right side, what it will do, it will make somewhat better mesh. Okay, it will make some better mesh by, see, if you increase the relevance to positive side now, see what happens means either we have to increase the number of elements or we have to decrease the number of elements. If you increase number of element means number of nodes will get increased, number of equations will get increased. Based on that one, it will take the time to solve. But whereas when you decrease the element, if the number of element is decreased, then the nodes of the elements also get decreased, and it will take less time to perform the analysis. Usually, what happens if we are getting, for example, okay, suppose for example, if I am saying that if you increase number of elements and perform the analysis, in that time what happened, we will get some more accurate results compared to the element which has less number. Then everybody will go for the fine more elements are the results only. Why? Because we got the accurate results there. Then why we are using this less element analysis? I already said that time also matters here. Sometimes what happens, you don't have that much time to solve very fastly. Like you cannot find that much big difference, but little difference you can find here. Okay, so that is the reason what happened here. We have to choose this option. It will take, suppose for example, I have taken this machine here. It will take around some 10 minutes. Just I am taking the example. Whereas when you go for the negative value, like if you decrease the relevance here and if the number of elements will get reduced there, in that case what happens? The analysis time, like it will take only 5 minutes to solve. Why? Because we don't have that much elements there. So like that, so we have to think and we have to consider everything while performing the machine. No? it will make like this. I am changing this one to negative side and update. See here, number of elements get decreased. Very less number of elements we can find based on that one. Very less nodes we have. And see, whatever static, like how many elements are there, how many nodes are there, we can find here. Here you can find the static option. If you click here, it is showing that nodes are 808 and elements are 411. So here directly we can find here. So right now what I am doing, I am changing the relevance to positive to check what is the static. See here right now we are getting 4,758 elements and 8,141 nodes we are getting. So based on the static only we have to think. This is my relevance. So what I will do, I am making this one like 0. Means default it is 0 only. That is the first option, relevant. Now after that one I am going for the sizing. Sizing is based on our requirement only again. Suppose for example what happens, sometimes we have to specify the element size. Means what is the size of element you require, thing we have to specify this. That thing we will discuss later. First of all I will go for use advanced selection, advanced size function. If you make this one on proximity, on curvature, on proximity, on fit. Initially if it is off, so what happens, you will get this kind of machine here. If you on the proximity only, so wherever curvatures are there, it will make convert fine mesh. Okay, sorry, wherever edges are there, these kind of things are there, it will make a fine mesh, like some small elements they will create for proper capturing of the area. For proper capturing of the area, if you choose the option proximity, it will make these edges wherever the shape is, like wherever the elements are very small, in that case it will make convert fine mesh. Fine in the sense it will capture all the area very nicely. That one we can say as a fine. If you choose the option here curvature, so wherever curvatures are there, at that location it will make some fineness. Here it is not making. Why? Because I don't have any curvature body here. If we have any fillets here, at the time we can able to see it will make some fine mesh at these locations like curvature shape. The next thing is proximity and curvature. Suppose for example if you are making both proximity and curvature on at the same time, so in that case it will cover, see here it will make like this, and at this if we have fillet or any curvature body, in that case also it will make some fine mesh at that location. Right now we can't able to see. So inside of this one, see the bottom one you can find somewhat here, somewhat fine mesh you can find here. Here you can find somewhat big elements compared to here. Why? Because here at the bottom, the top side we have some curvature like circular thing is there. So due to which it is making somewhat better mesh, fine mesh like this by reducing the element size. Okay, I am making this one off now. Now I am going for the next option. Relevance center. See here we have an option relevant. The other one is relevance center. So in relevance setting, we have to give either positive value or negative value. In relevance center option, here you can give the proximity, like how much fine or how much curves you want to make your object. If you choose the option like curves, it will make like this. If you choose the option like somewhat better meshing I want here, so in that case you can choose here medium. Then update. So what happened here? It will somewhat fine mesh it will make, somewhat better mesh it will perform here like this. Okay, if you choose the option here fine, so very small elements it will make, and it will cover each and every feature of your body like this. This is your fine mesh like that. Like that it will perform the mesh here on the body. Okay, that is my relevance center. Like three options we have here: curve, medium, fine. If you go for curve, some rough mesh it will do. Medium medium, what we can say, mesh, medium quality of mesh will make by capturing some features here, by considering some features it will consider, and it will make the mesh properly. If you go for fine, it will capture each and every feature and it will perform the mesh on that body. The next thing is, okay, next thing is element size. Here you can able to specify the element size. Before that, what I will do, I will go for this one and I will choose the option curse update. Now see here, this is my element. See here, every element are not in same size. Different sizes are there. So what I will do now, I will change the element size to, for example, 1. Update. If you give the element size here, what it will do, it will take the element size as 1 mm and it will perform the mesh. See here, right now if you go to zoom in here, all the element size is 1 mm only here. Okay, all the element size are 1 mm only. So like that we can able to give the element sizes also here. Either it will be 1 or less than 1 it will take, not more than 1. That is my element size. Suppose for example, if you have the assembly bodies, right now it's a single body only. If you have assembly bodies, you can choose active assembly. If you have only part body, you can go for part body. Okay. Right now you cannot find why, because we have specified the value here. So part body means, suppose for example, if you have a single part, you can perform. Suppose if you have an assembly also. Okay, for example, if you have an assembly, and here initial size speed if you are choosing as a part. So in that assembly, okay, in that part, what is the smallest feature is there? What is the smallest feature is there? Based on that smallest feature, it will perform the analysis. Means meshing means it will consider, the first thing it will consider as what is the smallest part size. So based on the smallest part size, it will perform the mesh to all the bodies. If you go for assembly, it will check the smallest part. Here in part option, it is checking the smallest feature in a particular part. If you go for assembly, in that case, what it will do, from all the assembly, which is the smallest part, based on that smallest part, it will perform the analysis, it will perform the meshing throughout the assembly. Okay, now go for the option here. Active assembly. If it is assembly means, then we can able to see here. If I go for part update, so based on the part option, like if we have the assembly only, then only we can properly see this thing. Right now we don't have the part assembly. So this active assembly means, here we have two types of assemblies are there: active assembly and fully loaded assembly. Active assembly means whatever on which part we are working, that is my active assembly. So based on that one only, it will take as a meshing operation. If you go for fully loaded means, some parts will not be an active here in the particular assembly. So in that case we have to, and then you have to, that one also you want to consider means you have to go for fully loaded assembly. Smoothing, if you go for smoothing here, smoothing is nothing but, suppose for example, if you have a element here also same like this. one only. Like we have the option like relevant center here, it is same like that only. Here also you can find three options: low, medium, high. If you go for low, wherever curvatures are there, it will not consider anything. It will perform the mesh without considering those things. Low, okay, it's updated already. Now if you go for medium, why it's not taking? Why it is not taking this value? What I will do now, I will make some fillets here on geometry. So that STP format mesh structural import geometry then the next option you can find here is fast and slow. Now how it is like that means, suppose for example if you have a body like this and here I have one like this for example. And for example, if you have any hole here, so here, if you go for the fast option now, so what it will do means it will make a single element like this single. If you go for slow option, it will make a multiple elements to make here. Like this. Okay. We'll check in Ansys here whether it will work or not now. The hole should be somewhat here, then only we can able to understand the thing. Now generate the mesh. I will move active medium fast, then here we can find the options like slow update. Here we can also, if the hole is here somewhere in the corner side, then only we can able to see that thing. Right now it's not showing. So I shown you like that only. Like if you go for fast option, here you can find only one element, but when you go for slow, it will make multiple elements here at the corner location like that. The next thing is span angle center. It is also same like that only. When we can able to see the span angle center means, suppose for example I have the geometry something like this, cone kind of shapes. These kind of shapes we have. So if you go for an angle, here we can find three options are there: curves, medium and fine. So at these location it will make a mesh properly. Like for example, if you go for curves, randomly it will make like this. That's it. When you go for medium, it will add one more element between this thing, like. But when you go to fine, it will make very fine meshes here, like this, by increasing number of elements. That is my span angle. I am choosing the span angle curves here. I am going for the next one, that is medium. Update. Here you can find some fine meshes here. And if you go for fine, if you go for the option fine here, it is increasing the number of elements in the location, curvature. So like that we can manage the thing. Here also we can find the number of elements get increased here. Here also we can find the number of elements increased. So wherever the curvature shapes are there, at that location we are using this option. Okay, span angle. Then minimum edge length. Well, like initially we have given the element size as 1 mm now, so like that we can able to give the minimum element size also, like how much element minimum, like 1 is your general average we can say, or general value it will take 1. Sometimes what happens, 1 element size also will not capture the feature. Why? Because either the element will become bigger than the feature. So in that case, you have to specify the minimum length of your mesh element. How much you require, minimum length. So that is also going to choose here by using this option. That is my sizing option. The next option we can find here is inflation. The next option is inflation here. Inflation we can give, like it is like a, what we can say, quality. Inflation it's a kind of quality. So based on the quality value, we can able to specify the sizing. Inflation, use automatic inflation. No, I want to use the manual one. Program control is there. All faces in chosen, names selected. If you go for this one, we can able to choose the faces here. Apply. Then the transition ratio, maximum layers, how much you want, growth rate, how much you want. Means it is a kind of manual inflation. So by selecting that phase, we can able to specify what is the transition ratio required and minimum layers, how much you want. I want 10 layers minimum, and update. Why this option is not highlighted? That is a problem with the backward. Program control means automatically it will take this value, okay, on that particular ratio, how much, what is the requirement you have here. Based on that one, it will perform the mesh. Inflation means it's based on your like manual machine. We can say we can able to give some values like transition ratio, maximum layer how much you want, and growth, like when the element size is getting increased, so what is the growth rate is required. So like that we can give here. Okay, inflation not that much we are reading. Patch conforming options, triangular surface measure, program control you want, or advancing front you want, just use the option and you create the measure. These options are not that much important. Why? Because mostly we are performing the mesh based on sizings and relevance. Here also it's like I said, inside these are these all are internal settings here of machines. Defeaturing. We will go for defeaturing here. What is defeaturing means? Not from here. I will take from here defeaturing. If you want to defeature anything, we can able to do here. I think we can able to find the thing. Pitch tolerance I'm giving like 1 for example generate pinch. Automatic mesh based on default tolerance. Okay, it's not working here. I will go for some other option. What is pinch? Like defeaturing or pinch we can say. Actually, defeaturing also we say and pinch also we can say. Means what it will do means, suppose for example I have this geometry here, like this extra portion is there. Now I don't want to do mesh on that extra portion. So in that case we can remove here by right click on mesh. Here you can find different type of meshing as well. So methods I will show you later. First I will go for the option here pinch. So what pinch will do means it will remove the extra portion. Like if you want to remove any geometry from your measurements, you can able to do. Master geometry is I am selecting here the edges. Just select this bottom edges. Apply. Now slave geometry we have to specify here. I am giving my slave geometry. Apply. The pinch control was ignored because the tolerance is too small. I'm giving the tolerance like 10 mm for example. Still too small. I'm giving the tolerance like 2 mm. Still is the tolerance is too small. I'll give here some 200. So mesh connection or pinch control is because the tolerance is too large. It is taking too small or it is taking too big. It's getting filled here. Now see here, that part has been removed from here. Now you can able to see. Okay. Now you can able to see the extra feature which we created now, bad, that thing got removed from here. That one we can say, if any feature if you want to remove from the mesh, you can able to remove with the help of this pinch option. Right now I am removing this one. Why? Because of the tolerance value, it is making some headache kind of thing. That is one pinch value. The next thing is methoding. If you go for method, select the geometry, apply what you want. See, initially it is taken as a tria element. I don't want tria here. I am taking here tetrahedrons I want here. Why it's not giving head dominant? So all tetrahedron means tria or tetrahedron both are similar only. So triangular element it is making here. If we go for hex dominant, is not sure. One more option is there hex dominant. If you choose that option, which will make a brick element like square box element created, but it's not showing that option here. It's not showing here. That option. Like one more option is there for you, that is hex dominant. What it will do means it will make a hexagon element. The next thing is sizing. Here also by using this option also we can able to specify the sizing here. There also we have checked. Here also by using this option also we can able to specify the sizing here. So go for sizing, select the geometry, apply. Element size how much you want, I am giving 1 mm. If you change there, okay, if you change in mesh setting, what happened, we cannot again able to change that value. But here we can able to delete this body sizing, so automatically it will take the default value. Now you can find here all the element sizes are equal. You check everywhere it is, whatever the value is specified there, the same value is taken for the complete mesh, for complete object. 1 mm. Like that we can able to keep the sizing from. Okay, that is the body sizing. That is body sizing. The next option we can find here is contact sizing. Contact sizing is required the assembly geometry now. Assembly geometry is on here. I will just show you that option how it will work. Suppose for example, if you have two components are there like this, and some components is intersecting like this. Okay, so in that case, what happened means it will capture these portions properly. Like wherever the contacts are there between the meshing, those things it will capture with proximity. Means with fine mesh it will capture those areas. Okay, that is the contact size. I don't have the assembly body. Face meshing. If you go for face meshing here, we can able to select the geometry on which face how you will require the element. For example, I want on this face, apply, and what type of mesh you required here. Constant call to advance. Okay. So on that particular geometry here, when you see this face, you cannot find a proper mesh. Like randomly they have placed the like it has placed the element. But whereas when you come to here, you can find some fine mesh on this. Like that, we can able to do the face mesh. Now see here how fine it's making us. See here how the elements are arranged here. If I go for space meshing, selecting this space, apply, update. Now you can able to see how elements are arranged properly here. See, like that it will work. Understand this one? Any doubt, guys, here?
No, sir. No, sir.
Sorry? Understand,
No,
guys?
sir.
So like
Yes,
that
sir.
we can able to do the meshing. I want bottom side also proper mesh. So whatever the spaces I selected there, so those areas it will make the proper meshing. Like